Hey guys, welcome back to the channel. So today we would be solving this first problem of biweekly contest 163. So it is minimum sensors to cover grid. Okay, so let's go through the problem statement. So we are given a grid of dimensions n into m and an integer k, and a sensor is placed at a particular cell having coordinates r and c, and this cell covers all the neighboring cells having Chebyshev distance from RC at most K. Okay, and the Chebyshev distance between two cells having coordinates R1 C1 and R2 C2 is the maximum of the difference between the rows and the difference between the columns, and we take their absolute value, and which one is the maximum is the Chebyshev distance between that two cells. Okay, so our task is to minimize the number of sensors required to cover every cell of the grid. Okay, seems to be an interesting problem. So let's go through this first test case and then understand this problem. So let's try to make the grid first. Now, first of all, let's see how much particular distance can be covered in any of the directions from a particular cell using Chebyshev distance. We consider this cell where the sensor is placed, and let's say we are using another cell, this cell. Let's try to consider the Chebyshev distance between this. So the Chebyshev distance between this would be 4 minus 2. This part would be 2, and the row here is the same row. So 1 minus 1 equal to 0, and maximum among this would be 2. Okay, so the distance till this point is 2, and we can see that starting from this, here are only 2 cells. Okay, let's consider this diagonal part now. For this particular cell, the row would be 3, and here row would be 1, so the difference would be 2, and similarly here the column is 4, and the column for this cell is 2, so it would be 2. Okay, great. And we can see that here also 2 cells are there. Similarly, if we consider this vertical part, this would be covered, because starting from this, the horizontal distance would be 1 minus 3 equal to 2, and as the columns are same, so it would be 2 minus 2, which is simply 0. Okay, so we know that if we place the sensor at this particular cell, then it will cover this part, this part, this diagonal part, and this part too. Okay, similarly in the upward direction it will cover this part, and as there are no more extended cells here, it will cover this part too, this part, and this particular part. So this means that it will cover k cells, which is 2 cells in all of the particular direction. Great. Now let's consider this first test case and try to derive the answer based on this intuition. Now let's consider this first example. So here the Chebyshev distance we can travel in any of the direction is maximum k, which is 1. So let's say we place the sensor at this point. So in the upward direction we can travel one part, in the diagonal, these diagonals, and in the horizontal direction too. Okay, so this part would be covered if we consider this k value as 1, and the cell where the sensor is installed is this cell. So now the problem boils down to how much these squares can be added to this grid such that the complete grid is covered. So we know that starting from any cell, we can go to k in upward direction plus k in downward direction, and this 1 for particular cell. So the total would be 2k plus 1 in the vertical direction, and similarly we have 2k plus 1 in the horizontal direction. So now we know that the side of the square is 2k plus 1. Okay, so we want to see how much this 2k plus 1 can be fitted in this dimension of the grid. Okay, so here the dimension is 4. So here n equal to 4, m equal to 4, sorry, uh, vertical direction would be 5 divided by 2k minus 1, sorry, plus 1, and the k value here is 1, so it would be 5 by 2 into 1 plus 1, which would be 5 divided by 3. It would be simply 1 point something, and we will take the seal of this. We will take the seal of this value. Since it would be somewhere around 1.7, it would be 2. Okay, similarly here for the horizontal part, we again have 5 divided by 3, like this 3 came from 2k plus 1, and here too it would be 1.7 or 8 something, and then the seal of this value would be 2. So now as we are considering a 2D grid, the total number of small squares which can be added into this grid would be 2 into 2, which would be 4, and this is our answer.
Okay, so this is the code for this problem, and you can go through this solution. So basically, this is the same thing which we discussed. So thanks for watching and subscribe to the channel for more such videos.